Let's continue with projectiles. So we have much to derive, many formulas to derive. So we started with maximum height. So considering vertical motion, so we are going to use this diagram. Maximum height is the capital H here. So this is the vertical displacement, and then this X is the horizontal displacement. So the velocity at which the body is projected has two components, the X and then the X component and the Y component. So this is one is the range. So maximum height, you're going to use the vertical motion. So considering vertical motion, initial velocity is the u sine theta. For the vertical motion, as we say that the velocity has two components, and then the acceleration is negative since it is upward motion. Then at maximum height, v is 0. Wherever something is thrown in space, when it reaches its maximum, as it is changing direction to come back, it first rests, then it changes direction. Even if you are the one moving at a corner, as you reach the corner, you rest a bit and then change direction. So that's why they are saying at maximum height is v easy, that final velocity is 0. So using the third equation of motion, that v squared equals u squared plus 2as. V is 0, u for the initial velocity, vertical motion is this. So it's square, and then we said it's negative v, that's why we have negative 2bh. And so we come up with such a formula or a derivation for maximum height. And then when we come to time taken to reach the maximum height, so we have our h, but there is time taken to reach it. Still v is 0, u we know we have it, and then our acceleration is negative g. And so when we substitute and simplify, our t is u sine theta over g. This is time taken to reach the maximum height. We also have the time of flight. So time of flight is our capital T, and so we're going to use the second equation of motion. So they're saying that when the body falls back to the ground on the same level of displacement as above, vertical displacement is 0. So if I have a pen at this point here, if it is here, it's on my hand, and then it moves up, and I throw it up and then it comes back, it is not vertically displaced because it has been here and now it's here. If at all it moves from the same level here and it comes here, it's the same level, so it has no vertical displacement, but horizontally it has been displaced. It's here. This point and this point, they're on the same level vertically, and so the body has not moved. If it moves here and it comes back here vertically, it has not been displaced, but it has been horizontally displaced because horizontally it has covered the distance. It has covered the distance, and so it has changed the position horizontally, but it has not changed the level vertically. Yeah. So we take the vertical displacement s to be 0. So our 0 equals the u for initial velocity for vertical displacement is this, and then our t, capital T, minus a half g, we are taking negative g as acceleration due to gravity, and then a capital T. So we have to simplify mathematically, we make a t the subject. Here we are dividing by t, and so we have a half dt equals v sine theta. So we make a theta subject, and we have 2u sine theta over v. But when we simplify further, this is the expression, the final expression. But when we simplify further, we get to know that this time taken to reach the time of flight is it twice the time taken to reach the maximum height. We have more derivations. Yeah. Let's continue. We are going to find derive range. So considering horizontal motion, remember range is along the horizontal. Considering horizontal motion, range, it is velocity times time, but the horizontal velocity along the horizontal is u cos theta times that time of flight. And so we have u cos theta times 2u sine theta over g. Remember we derived this already, the time of flight. And so when we try to to simplify. So you find that u squared, this u times this u squared, 2 sine theta cos theta, and so over g. But 2 sine theta cos theta is the same as 2 sine 2 theta. So range is u squared sine 2 theta over g. But for maximum range, our angle theta is 45. And so if it is 45, 2 theta, that's 90. So sine 90 is 1. Sine 2 theta is 1. So maximum range now is u squared over g over g. So we move to the equation of the trajectory, this one here. So equation of the trajectory, we want to see that equation that describes the path from this point of projection until when the body hits the ground. So at any time, the horizontal displacement of a projectile motion x is this. So horizontal displacement x is always the velocity times the time of flight. So we are talking about, so we've considered these two displacements. This x as the horizontal displacement and then y as the vertical displacement. So at any time, this is the horizontal, this is the velocity for the horizontal, and then the time of flight. So it will give us the horizontal displacement. Then at any vertical displacement, we use the second law of motion. And so we substitute for vertical displacement, whereby it is y equaling to u sine theta as the vertical component of velocity times the time of flight. Since it's vertical motion and we are moving up, it's negative velocity, negative acceleration due to gravity, and so t squared. So as we move, we know t here. So we are making t the subject from this equation of the horizontal displacement. So t is x over u cos theta from this equation 1. So we are substituting in equation 2 where we see t. So it's u sine theta x over u cos theta. And also where there is t squared, we say x squared over u squared cos squared theta. As we continue to simplify, you will find that sine theta over cos theta is tan theta. And these u's cancel. So we remain with the x tan theta. And so we move this side here, there's nothing to cross. So it is x squared as the numerator, and then 2u squared cos squared theta. They remain as they are. So here x tan theta, here x squared over 2 squared. 1 over cos squared theta is the same as sec squared theta. So it is this. But we know from the trigonometrical identities that sec squared theta is equivalent to 1 plus tan squared theta. So we get that final equation. But equation 3, 4, and 5, those equations are the equations of the trajectory. So you can use any of the 3, provided you know any of them. So let's continue.